Very good morning, students. So, today we are going to deal with a new chapter, solar radiation, heat balance, and temperature. So, students, the sun radiates heat and light energy all directions, and this is what known as solar radiation. The amount of solar radiation reaching a given area is called insolation. The flow of energy from the sun to the earth and then into the sun space, these are complex process, and this involves energy transmission, storage, and transport. New energy transmission means, now what does it mean? Sun lies transmitting energy in the form of radiation, and radiation varies emission of energy in the form of electromagnetic waves or moving subatomic particles, whereas energy storage and transport occurs in the form of heat. So now solar radiation is the only primary source of light and heat on the earth. The earth receives its heat from solar radiation, as you all know, which is a tiny radiated energy from the sun. And the sun radiation made up of three parts. What are these three parts? First is white light, which has seven colors, and second is infrared. It is the heat of the sun, which is not visible, we cannot see it. Number three is ultraviolet rays. Now the sun also emits atomic particles, and these are called solar wind. And students, these solar winds are changed in electrons, and this can be harmful for our planet, but we are protected from the solar wind, solar wind, by the magnetic field around the earth. Earth is covered by the magnetic field. So everything is in nature is moving in cycle, and one thing is permanent, and that is change. So let's understand what is solar radiation. So students, solar radiation, the earth is geoid in shape. It resembles a sphere. So different part of the earth receives different amount of sunlight. The equator and angle of incidence increases as we move towards the poles. So we can say the rays of the sun become more and more oblique as we move towards the poles. The duration for which the sun rays would falls also vary from the equator towards the poles. The top of the atmosphere and the sun abstracts a very small portion of sun energy. On an average, the earth receives approx, we can say, 1.94 calories of the heat per square centimeter per minute at the top of the atmosphere. Okay, suppose this is, okay, I'll show you through this. So the sun is not at the certain center of the ellipse. Suppose this is sun. So there is a variation in the distance between the earth and the sun. During its revolution around the sun, earth is farthest from the sun. Okay, here you can see nearest, and here you can see farthest. That is 152 million kilometer on 4th July. Okay, 100, how much I said? 152 million kilometer on 4th July. 4th July. This position is called aphelion. What does it call? It is called aphelion. On 3rd January, here you can see this is winter season. It is the rainy beginning of rain, rainy season. 3rd January, nearest to the sun, that is 1 47 million kilometer, and this position is called perihelion. What does it call? Perihelion. It is aphelion or it is this position is called perihelion. So therefore the annual insolation received by the earth on 3rd January is lightly more than the amount received on 4th July. However, the effect of the variation in the solar output covered by other factors like land and sea, atmosphere circulation. It affects on daily weather changes on the surface of the earth. Clear? So in the next video we will discuss about the variability of insolation at the surface of the earth. Till then, thank you so much, students.